Assalamualaikum everyone, you are watching Science with Arsan Bathun. Today we'll be solving the latest paper October-November 2025 part 3. So we'll be starting from question number 4. The diagram shows a force pulling a block up a ramp. So this is the block that is being pulled upward, and the distance which is rising, that would be 0.82 meter, and the force pulling it is 120 Newton. Show that the work done by the force is about 440 joule. So we need to use the formula work done equals to force into distance moved. So the force here given is 120 Newton, and we always know that the distance moved will be always in the direction of the force, or it should be parallel in the direction of the force. So what is the distance in the direction of force? That is 3.7 meter, right? So let's solve it then. So work done can be given by force into distance, and the force is 120 Newton, and the distance moved in the direction of force is 3.7 meter. So 120 Newton into 3.7 meter gives us 444 joule. That is about 440 joule. About means that it is estimated to 440. Okay, then let's move on to part B. The block gains 12 joule of energy in its gravitational store when it is lifted through a height of 0.82 meter. Calculate the mass of the block. So 12 joule is the GPE gained, gravitational potential energy gained, and this can be given by the formula mgh. So we know that GP is 12 joule. In mass we need to calculate it, so let's keep it m, or you can give any variable if you want, and G is always 9.8 if the question does not specify it, otherwise it will be 9.8. And the height we have already found in the question, that is 0.82 meter. So let's subtract m from here, that will be 12 joule divided by 9.8 into 0.82. So this will give us the answer 1.5, or we actually get 1.46, that can be estimated to get 1.5 kg. Okay, so this is our answer for part B. Let's move on to the next part. C says a student states that most of the input energy is destroyed when the block is pulled up the ramp. Comment on student's statement. So the student states that most of the input energy is destroyed when the block is pulled up the ramp. Yes, because when pulling it up, there is friction between the ramp and the box. So that friction will be acting as a resistive force, and due to the friction there will be a heat energy stored, or the energy will be converted, some of the energy will be converted to heat energy, and this will cause some energy loss. So energy cannot be destroyed because we know that law of conservation of energy states that energy cannot be destroyed or created. So that would be our answer for part C. So let's write our answer. First of all, according to law of conservation of energy, energy cannot be destroyed. But can be converted to other forms of energy. Here, some of the energy will be converted to friction and heat between the block and the ramp. is our 2-mark answer. Okay, moving on to question number 5. This question is about radioactivity. Uranium-238 decays by emitting an alpha particle to become an isotope of thorium. Complete the equation for the alpha decay of uranium. So this is very easy equation. We know that alpha particle has a mass of 4 and a charge of 2. So alpha particle acts as a helium nucleus. So this is a shortcut to remember about alpha particle mass number and atomic number or charge. And uranium-238 has a we need to find the atomic number for it. That can be 90 plus 2, that will be 92. And for thorium, the mass number will be 238 minus 4, that is 234. Okay, then moving on to part B. The isotope of thorium produced in the decay of uranium-238 is also radioactive. Thorium decays by emitting a beta particle. Describe how the structure of thorium nucleus changes when a beta particle is emitted. So how it will be, so it talks about another isotope. So if it emits a beta particle, we know that the neutron number decreases by 1 because there is a electron removing from it. A beta particle acts as an electron, and the proton number increases by 1. Okay, so let's describe about the beta particle. What will happen to the structure of thorium nucleus? The neutron number decreases by 1, and the number of protons increases by 1. Okay, let's move on to part C. A teacher demonstrates radioactivity using a radioactive rock. The rock contains uranium-238 and other radioactive isotopes. The teacher takes precautions to reduce the risk of contamination and irradiation by the radioactive rock. So this is a safety precaution that would reduce the risk of contamination by the radioactive rock. So we can use gloves, we can use any foot protection so that the rock does not fall on our foot, and so that the students who are doing the experiment does not get hurt. So one can be wearing gloves, or instead they can use tongs, long hand tongs. Use long hand tongs to hold the rock. And there can be other answers. For example, student can also wear foot protection. Or we can also store the rock into a lid box. Store the rock after use into a lid box so that no radiation is escaping from it. C2 says, suggest a safety precaution that would reduce the risk of irradiation by the radioactive rock. So for irradiation, we can use minimum exposure time. For example, if you're doing the experiment, let the experiment to do by one student for a while and then use another student to do it, so that the exposure time can be less. And we can also use a way in which there is a barrier between the rock and the student or teacher, and even after using the rock, the student can store the rock in a lid box. Any of these answers. So let's choose the most appropriate one, which is we can use short exposure time for each student to do the experiment. last part for this question is the teacher measures the amount of radiation emitted by the radioactive rock in a time of 1 minute using a Gigermuller tube or GM tube and counter. The student repeats this measurement to obtain a total of 5 measurements of the count rate. The table shows the teacher's results. So these are the count rates per minute. Calculate the mean count rate. So we need to first find any anomaly. So here the anomaly is 35 because it does not fit the trend. So let's add the other 4 numbers, 54 plus 58 plus 52 plus 55 divided by 4. So which will give us actually 4.75, and the question says to write it in 2 significant figures. So you can estimate 4 can be estimated by using the next number to it, which is 7. So it will be estimated to 55. So our answer will be 55 counts per minute. So this is the end of our video today, and please subscribe our channel for more videos like this. Thank you.